Hello, and welcome. Tonight, we'll be exploring a question that sounds surprisingly simple at first. What is the solar system moving through right now? It's the kind of question that rarely appears in everyday life. Most of the time, we think of space as a backdrop, a silent stage upon which planets and stars slowly drift. We imagine the solar system floating through emptiness, surrounded by darkness and distant points of light. But the reality is much more interesting. At this very moment, as you settle into a comfortable position and listen to the sound of these words, you are traveling. Not metaphorically, not philosophically, physically. You are moving through the universe at extraordinary speeds, and yet it doesn't feel that way. Your room feels still, the walls are quiet, the floor beneath you seems perfectly motionless. Nothing suggests that you are participating in one of the longest journeys imaginable. That feeling of stillness is one of the most convincing illusions in everyday life. Imagine for a moment that you are lying peacefully in bed on a calm night. Perhaps the air is cool. Perhaps there is a faint sound somewhere outside. Everything feels settled and unmoving. Yet beneath that calm surface, the Earth is turning. Our planet completes one full rotation approximately every 24 hours. Because of this rotation, every sunrise and sunset is part of a continuous spinning motion that has been happening for billions of years. If you were standing near Earth's equator, you would be carried around the planet at a speed of roughly 1,600 kilometers each hour. Of course, you don't notice this movement because everything around you is moving together. The atmosphere moves with the Earth. Your home moves with the Earth. Even the chair or bed supporting you is moving with the Earth. It's similar to sitting comfortably inside a smooth train. If the ride is steady enough, you can forget that you're moving at all. But Earth's rotation is only the beginning. While our planet spins, it is also traveling around the sun. Every year, Earth completes one vast loop around our star. Along this journey, our planet moves at approximately 30 kilometers every second. Before you finish listening to a single sentence, Earth has already traveled many kilometers along its orbit. Without any effort on your part, you are riding a planet that continuously circles a star. And even that is only one layer of a much larger story. The sun itself is moving. For much of human history, people imagined the sun as a fixed point around which everything else revolved. Today, we know that the sun is also a traveler. Together with all the planets, moons, asteroids, comets, and countless smaller objects of the solar system, the sun is orbiting the center of the Milky Way. This is an immense journey. The distance involved is so enormous that ordinary comparisons quickly begin to fail. Our solar system resides far from the galaxy's crowded central regions, moving through one of the Milky Way's spiral neighborhoods. As it travels, the sun moves at about 220 kilometers every second. To put that into perspective, if you could maintain that speed on Earth, you could cross entire countries in moments. Yet in the vast scale of the galaxy, even this tremendous motion becomes part of a slow and graceful dance. One complete orbit around the Milky Way takes roughly 230 million years. When dinosaurs walked across ancient landscapes, the sun occupied a completely different position within the galaxy. In fact, since the sun formed about 4.5 billion years ago, it has completed only around 20 galactic orbits. Only 20, a number that feels surprisingly small. The Milky Way is simply that large. And so, as you listen tonight, you are experiencing several journeys simultaneously. You are rotating with Earth. You are orbiting the sun. You are traveling with the sun around the Milky Way. And beyond that, The Milky Way itself is moving through the wider universe. The layers stack upon one another like currents in a river. Some move quickly, some move slowly, some take hours, some take hundreds of millions of years. Yet together, they create a remarkable reality. Nothing in the cosmos is truly standing still. Not the planets, not the stars, not even entire galaxies. For a long time, scientists focused on measuring these motions. They wanted to know how fast Earth traveled, how stars moved, and how galaxies drifted through space. But eventually another question emerged. If the solar system is moving, then what is it moving through? The answer may seem obvious at first: space. But that answer turns out to be incomplete, because space is not simply an empty void. The region between stars is not blank. It contains matter, it contains magnetic fields, it contains energetic particles, it contains traces of ancient stars that lived and died long before Earth existed. In a sense, the solar system is traveling through a real environment, a cosmic landscape, an invisible one, certainly, but no less real. Imagine a ship crossing a calm ocean at night. The passengers aboard might focus on the vessel itself, the deck, the cabins, the lights glowing softly against the darkness. Yet the ship is also surrounded by an environment. There are currents beneath the water, winds above the waves, mist drifting across the surface. The journey depends not only on the ship, but also on the ocean through which it sails. Our solar system may be more similar to that ship than people once imagined. Surrounding us is a vast region of interstellar space, filled with subtle structures and invisible boundaries. The Sun carries its family of planets through this environment as it follows its ancient path around the galaxy. For most of human history, nobody knew this surrounding environment existed. Today, however, spacecraft have begun to explore its edges. Scientists have mapped parts of it, and little by little, a picture has emerged of the remarkable region through which we are currently traveling. It is a place known as the local interstellar cloud, a faint and nearly invisible cloud drifting among the stars. And as we move farther from the familiar surroundings of Earth, the story of that cloud begins to reveal something unexpected about our cosmic home. As the solar system continues its quiet journey through the galaxy, it helps to pause and consider a simple assumption that many of us carry without even realizing it. When we imagine the space between stars, we often picture a vast emptiness, a dark void, an enormous stretch of nothing. Stars appear as isolated islands of light separated by unimaginable distances, and it is tempting to think that the regions between them contain very little at all. In a sense, that intuition is understandable. Compared with Earth's atmosphere, interstellar space is astonishingly empty. Even the best vacuum chambers built by scientists on Earth contain far more particles than many regions between the stars. Yet empty does not mean absent, and quiet does not mean lifeless. The space through which our solar system is currently traveling contains matter. Not much matter by earthly standards, but enough to create an environment that astronomers can study, map, and explore. Imagine walking through a thick morning fog. Nearby trees fade into pale silhouettes. The air feels almost transparent, yet tiny droplets surround you everywhere. The fog is difficult to see in detail, but it is there nonetheless. Now, imagine a fog so thin that it would be almost impossible for human senses to detect directly. A fog stretched across light years, a fog drifting between stars. That image comes surprisingly close to the reality of interstellar space. Astronomers use the term interstellar medium to describe the material that exists between stars throughout the galaxy. The name sounds technical, but the idea is simple. It is the environment that fills the spaces between stellar systems. Much of this environment consists of hydrogen, the simplest and most abundant element in the universe. There is also helium, along with tiny amounts of heavier elements created inside stars over billions of years. Mixed among the gas are microscopic dust grains, particles so small that countless numbers could fit across the width of a human hair. These ingredients are spread incredibly thinly across space. If you could somehow collect all the material found within a large volume of interstellar space, you would discover that there is remarkably little of it. And yet, over distances measured in light years, even a small amount of matter becomes significant. The galaxy is not a collection of stars floating in perfect emptiness. It is more like an ecosystem, a vast one, a slow one, but an ecosystem nonetheless. Stars form from clouds of gas. Stars live for millions or billions of years. Eventually, many stars return material back to space. Some release gentle winds throughout their lives. Others end in spectacular explosions that scatter newly forged elements across the galaxy. The oxygen you breathe, the calcium in your bones, the iron in your blood. All of these elements were created inside ancient stars long before the solar system existed. In that sense, the interstellar medium is a kind of cosmic recycling system. Material moves from clouds into stars, from stars back into clouds, again and again, over immense stretches of time. As you listen tonight, the atoms around you are participating in a story that began billions of years ago. Some may once have drifted through ancient nebulae. Some may have been expelled from dying stars. Some may have crossed vast regions of the Milky Way before eventually becoming part of Earth. The galaxy is constantly reshaping itself, slowly, patiently, almost imperceptibly. But there is more to the interstellar medium than gas and dust. Invisible magnetic fields thread through space as well. Here on Earth, magnetic fields are familiar in small ways. A simple refrigerator magnet demonstrates their existence. A compass points toward Earth's magnetic poles because of them. The Milky Way possesses magnetic fields too. These fields stretch across enormous distances and help guide the motion of charged particles moving through interstellar space. They are invisible, yet they influence the structure of the galaxy in subtle and important ways. Another ingredient of this environment comes from some of the most energetic events in the universe. These are cosmic rays. Despite their name, cosmic rays are not rays of light. They are fast-moving particles that travel across space at extraordinary speeds. Some originate from exploding stars. Others come from even more powerful cosmic phenomena. For countless ages, these particles have streamed through the galaxy, crossing vast distances before encountering planets, stars, and the protective boundaries surrounding stellar systems. Fortunately for us, the solar system possesses a remarkable shield against many of these incoming particles. We will soon explore that shield in greater detail. For now, it is enough to know that our cosmic neighborhood is far more active than it first appears. The darkness between stars is not empty darkness. It is filled with movement. Gas drifts through space. Magnetic fields stretch across the galaxy. Dust slowly migrates between stellar regions. Energetic particles travel in every direction. And together they create something that can almost be compared to weather. Not weather in the familiar sense of clouds, rain, or wind, but a form of galactic weather. Conditions change from place to place. Some regions contain denser gas. Others are more rarefied. Magnetic fields strengthen and weaken. Cosmic radiation rises and falls. clouds drift, structures evolve. The galaxy possesses its own slow-moving environment, unfolding across millions of years. This realization changes the way we think about our place in space. The solar system is not simply floating through an empty void, it is traveling through a landscape shaped by ancient stars, a landscape filled with invisible structures, a landscape that continues to evolve long after individual civilizations come and go. And at this moment, our particular location within that landscape is especially interesting, because the Sun and its family of planets are moving through a specific region of the interstellar medium, a region so delicate that early astronomers could not see it directly, a region so thin that it would seem almost impossible to detect. And yet it surrounds us right now. Astronomers eventually gave this region a formal name, the local interstellar cloud, though many scientists affectionately refer to it by a far gentler nickname, the local Fluff, a surprisingly humble name for the vast cloud through which our entire solar system is currently drifting. If you could somehow step outside the solar system and look back from a great distance, one of the first things you might notice is not a planet or a moon or even the sun itself. You might notice the environment surrounding them, not a solid structure, not a glowing nebula, but a vast, nearly invisible cloud quietly stretching through a corner of the Milky Way. This is the region astronomers call the local interstellar cloud. And right now, the entire solar system is drifting through it. The idea can feel surprising at first. Many of us grow up imagining the solar system moving through empty space, as though it were traveling across a perfectly clean stage. But as we discovered earlier, the galaxy is not empty. It contains gas, dust, magnetic fields, and energetic particles spread across enormous distances. Sometimes these ingredients gather into larger structures. One of those structures happens to be our current cosmic neighborhood. The local interstellar cloud is not especially dense. In fact, it is extraordinarily thin. If you could gather the material inside a large volume of this cloud and compare it to the air around you, the difference would be almost unimaginable. The atmosphere of Earth contains trillions upon trillions more particles. Even the emptiest vacuum chambers built in laboratories are often denser than parts of interstellar space. And yet, over distances measured in light years, this thin material becomes an environment of its own, a kind of galactic weather system through which stars slowly travel. Because the cloud is so diffuse, scientists sometimes use a nickname that sounds surprisingly casual. They call it the local Fluff. It is a name that feels almost playful, more like something you might find beneath a sofa cushion than a structure spanning light years across space. Yet the nickname captures an important truth. The cloud is soft, thin, diffuse, almost ghost-like. If your eyes could somehow perceive it directly, it would not resemble the thick clouds that drift across Earth's skies. It would be closer to a faint mist stretching through the darkness between stars. A gentle haze so delicate that it would barely seem to exist at all. And yet it does. The cloud consists mostly of hydrogen and helium, the same basic ingredients found throughout much of the universe. Hydrogen is the simplest element, containing just a single proton and a single electron. Helium is slightly more complex, but still remarkably simple compared with many of the heavier elements found on Earth. These gases drift quietly through the cloud, spread across immense distances. Parts of the cloud are electrically charged. Astronomers describe these regions as ionized. But rather than thinking of technical terminology, it may help to imagine a gas whose particles have become energized and influenced by surrounding radiation and magnetic fields. The result is a dynamic environment, even if its motions unfold far too slowly for human senses to notice. The cloud also contains magnetic fields, invisible lines of influence threading through space. These fields help shape the interactions between the cloud and the solar system moving through it. Although we cannot see them directly, they are part of the reason our cosmic surroundings possess structure rather than complete randomness. One of the most fascinating aspects of the local interstellar cloud is that scientists are still working to understand its precise shape and boundaries. Unlike a mountain or a coastline, there is no sharp edge marking where the cloud begins and ends. Its borders gradually blend into neighboring regions of interstellar space. The cloud is part of a much larger and more complicated collection of nearby structures. In some ways, it resembles a patch of mist drifting through a valley. You can often tell where the fog becomes thinner, but identifying the exact boundary is much more difficult. For many years, astronomers didn't even know this cloud existed. After all, how do you study something that is almost completely invisible? The answer came through patience, technology, and careful observation. Scientists began examining the light arriving from nearby stars. As starlight travels across space, it passes through the material between stars. Tiny amounts of gas absorb specific colors of light along the way. These missing colors leave subtle fingerprints hidden within the starlight. By studying those fingerprints, astronomers can learn about material that would otherwise remain unseen. The process is a little like walking through a forest after a light rain. You may never see the animal that crossed the trail ahead of you, but footprints in the mud reveal its presence. Similarly, the cloud leaves delicate traces within the light of distant stars. Over time, these clues allowed scientists to build a picture of our local interstellar environment. They discovered that the sun appears to be moving through this cloud at considerable speed. Or, depending on your perspective, the cloud is flowing past the solar system. In space, motion is often a matter of viewpoint. Either way, the relationship between the two remains the same. We are traveling together through a shared region of the galaxy. Researchers estimate that the solar system entered the local interstellar cloud tens of thousands of years ago. At the time, early humans were still painting on cave walls, crossing continents, and learning to navigate a rapidly changing world. Throughout the rise of civilizations, the construction of cities, the growth of science, and the development of modern technology, our entire solar system has remained inside this same vast cloud. And yet, on cosmic timescales, this stay may only be temporary. The sun's journey around the Milky Way is far from over. Just as ships crossing oceans encounter different currents and weather conditions, the solar system may eventually move into a different interstellar environment. Other clouds exist nearby. Other regions await. The local interstellar cloud is simply the chapter we happen to be experiencing right now. That realization adds an unexpected sense of movement to our place in the universe. We are not parked in a fixed location. We are passing through a landscape that changes over time. A landscape shaped by ancient stars and invisible forces. And surrounding the entire solar system is something remarkable. A vast protective structure created by the sun itself. A structure that stands between our planetary family and the wider galaxy. As the solar system drifts through this cosmic fog, that invisible shield quietly travels with us, carrying Earth and every other planet inside its protective embrace. As the solar system drifts through the faint mist of the local interstellar cloud, it does not travel alone. The sun carries something with it, something enormous, something invisible, something that extends far beyond the orbit of the outer planets. For most of human history, nobody knew it existed. Even today, it remains difficult to imagine because it cannot be seen with ordinary eyes. Yet every planet in the solar system lives inside it. This vast structure is called the Heliosphere, and in many ways, it resembles a giant ship crossing an interstellar sea. To understand the Heliosphere, it helps to begin with the sun itself. When we picture the sun, we often imagine a glowing sphere suspended against the darkness of space, a steady source of warmth and light. But the sun is not entirely still. It is constantly releasing material into space. From its outer atmosphere flows a stream of charged particles, known as the solar wind. Despite its name, this wind is nothing like the breeze that rustles leaves on Earth. You would not feel it against your skin. It is a flow of particles racing outward in every direction from the sun, hour after hour, day after day, year after year. For billions of years, the sun has been pouring this invisible stream into space. Imagine standing beside a fountain. Water continuously flows outward from its source, spreading into the surrounding area. The solar wind behaves in a somewhat similar way, except instead of filling a garden pond, it expands into the vastness of space. As the solar wind moves outward, it pushes against the material of interstellar space, and in doing so, it creates a gigantic bubble surrounding the solar system. That bubble is the heliosphere. Every planet orbits within it. Earth lives inside it. The asteroids, comets, and distant icy worlds all travel within its boundaries. The heliosphere moves with the sun as the solar system journeys through the galaxy. This is why the image of a ship can be so helpful. Imagine a vessel crossing a foggy ocean. Passengers aboard might pay attention to the decks, cabins, and lights. Yet, surrounding the ship is a protective hull separating the interior from the sea outside. In a similar way, the heliosphere creates a region where the sun's influence remains dominant. Inside, solar wind shapes the environment. Outside lies the wider galaxy. The boundary between these regions is not a solid wall. It is more like a frontier, a gradual transition where the influence of the sun begins to give way to the influence of interstellar space. One of the most important jobs of the heliosphere is protection. Throughout the Milky Way, high-energy particles travel across enormous distances. Some originate from exploding stars. Others come from powerful cosmic environments scattered throughout the galaxy. These particles are known as cosmic rays. Many travel at astonishing speeds. If they reach the inner solar system without obstruction, Earth and the other planets would experience significantly greater exposure to cosmic radiation. Fortunately, the heliosphere acts as a shield, not a perfect shield. Some cosmic rays still penetrate into the solar system, but the heliosphere helps reduce their numbers. It deflects many incoming particles and weakens some of their effects. You can think of it as a protective weather barrier surrounding our planetary neighborhood. Without it, the environment around Earth would be noticeably different. This protective role makes the heliosphere one of the most important structures in our cosmic surroundings. And yet, despite its importance, it remains surprisingly difficult to visualize. Part of the challenge is its immense size. The heliosphere extends far beyond Pluto, far beyond the familiar planets, far into regions that sunlight reaches only after many hours of travel. Its outer boundary lies at a distance so vast that spacecraft require decades to reach it. Even the fastest human-made explorers spend much of their existence crossing this enormous frontier. For many years, scientists assumed the heliosphere might resemble a simple sphere. After all, the solar wind expands outward in all directions. A spherical bubble seemed like a reasonable assumption. But nature often turns out to be more complicated. As researchers gathered more observations, new possibilities emerged. Some models suggested that the heliosphere stretches into a long tail, resembling a comet. Others proposed a shape more similar to a croissant, with two extended lobes trailing behind. Still others suggested a distorted bubble, continually shaped by interactions with surrounding interstellar material. The truth is that scientists are still learning. And that uncertainty is part of what makes the heliosphere so fascinating. We live inside it. We depend upon it. Yet we are still uncovering its exact structure. The shape of the heliosphere depends on an ongoing interaction. The solar wind pushes outward. Meanwhile, the gas, particles, and magnetic fields of interstellar space push back. The result is a dynamic balance, like a sail responding to changing winds, or a boat adjusting to shifting ocean currents. The heliosphere is not frozen in place. It responds to its environment. Changes in solar activity influence its size. Changes in the surrounding interstellar cloud can influence it as well. The galaxy and the sun are engaged in a quiet conversation, one unfolding over vast distances and immense periods of time. At the outer edge of the heliosphere lies a particularly important region, a boundary known as the heliopause. This marks the point where the outward pressure of the solar wind is finally balanced by the surrounding interstellar environment. Beyond this frontier, interstellar space becomes dominant. For decades, the heliopause existed only in scientific models and calculations. Scientists knew it should be there. But nobody had ever reached it. Nobody had crossed it. Nobody had measured conditions on the other side. Then, after one of the longest journeys in the history of exploration, humanity finally approached this distant border. Small robotic travelers launched in the 1970s continued moving outward year after year, decade after decade, patiently crossing the vast reaches of the solar system. And eventually, they arrived at the edge of the sun's great protective bubble. Their story would transform our understanding of the heliosphere forever. For most of human history, the heliosphere was completely unknown. No ancient civilization recorded it. No philosopher imagined its true scale. No sailor navigating Earth's oceans could have guessed that the solar system itself traveled inside a vast protective bubble. The heliosphere was simply too large, too invisible, and too distant to reveal itself easily. And yet, long before spacecraft ever approached its outer edge, scientists had already begun gathering clues. Some of the earliest hints came from an unlikely source: starlight. Imagine standing beside a window on a rainy evening. You look through the glass toward a distant street lamp. The lamp's light reaches your eyes, but along the way it passes through raindrops, moisture, and thin layers of mist. Although the lamp itself remains far away, the light carries information about everything it encountered during its journey. Astronomers use a similar idea when studying the galaxy. Light from nearby stars travels through interstellar space before reaching Earth. As it moves through clouds of gas, certain colors are absorbed. Tiny portions of the light disappear, leaving subtle patterns behind. These patterns act like fingerprints. They reveal the presence of material that would otherwise remain invisible. Over many decades, astronomers carefully studied these fingerprints hidden within starlight. Little by little, a picture emerged. The sun was not surrounded by empty space. Instead, it occupied a region filled with interstellar gas and threaded by magnetic fields. The local interstellar cloud slowly began to take shape in scientific understanding, but indirect evidence can only reveal so much. Eventually, scientists wanted something more. They wanted direct measurements. They wanted to know what conditions were actually like at the edge of the sun's influence. The challenge was enormous. The heliosphere is vast beyond ordinary comprehension. Even traveling at tremendous speeds, spacecraft required decades to reach its outer boundaries. Fortunately, humanity had already launched 2 explorers destined for exceptionally long journeys: Voyager 1 and Voyager 2. When these spacecraft left Earth in the 1970s, their original mission was not to study interstellar space. They were sent to explore the giant outer planets: Jupiter, Saturn, Uranus, Neptune. Their discoveries transformed planetary science. They revealed storms larger than Earth, complex ring systems, strange moons unlike anything previously imagined. By any reasonable standard, the missions had already been a remarkable success. But the Voyagers kept going. Year after year, they continued traveling farther from the sun. The planets gradually faded behind them. The familiar solar system became increasingly distant. Meanwhile, scientists realized that these spacecraft might accomplish something entirely unexpected. They might eventually reach the edge of the heliosphere itself. For decades, the journey continued. The spacecraft traveled through regions no human-made object had ever visited before. Outward, farther and farther, like small ships leaving a familiar coastline behind and entering unknown waters. Then, after one of the longest exploration missions in human history, something extraordinary happened. Voyager 1 crossed the heliopause, the frontier where the sun's protective bubble gives way to interstellar space. For the first time, a spacecraft built by human hands entered the environment between the stars. Not another planet, not another moon, interstellar space itself. It was a quiet milestone. There were no crowds gathered along a finish line, no dramatic fireworks, only streams of scientific data traveling slowly back to Earth across unimaginable distances. Yet the achievement was historic. Humanity had finally touched the broader galactic environment directly. The measurements surprised scientists in several ways. The density of particles beyond the heliopause differed from conditions inside the heliosphere. Magnetic fields continued across the boundary, but their behavior revealed important details about the surrounding interstellar environment. For the first time, researchers could compare theory with direct observation. Years later, Voyager 2 crossed the heliopause as well. Having 2 spacecraft pass through different parts of the boundary gave scientists a richer understanding of this distant frontier. Together, the Voyagers transformed the heliopause from an abstract concept into a measurable reality. They became humanity's first interstellar messengers. Even now, decades after launch, both spacecraft continue their journey through the galaxy. Their power supplies slowly diminish. Their instruments become fewer, yet they still carry a faint connection to Earth. Tiny signals crossing billions of kilometers of space. A quiet conversation between our world and 2 aging explorers. The Voyagers were not alone in helping us understand our cosmic surroundings. Other missions approached the challenge from different directions. One particularly important mission was the Interstellar Boundary Explorer, often known simply as IBEX. Unlike Voyager, IBEX did not travel to the edge of the heliosphere. Instead, it observed the boundary from much closer to home. You can think of it almost like studying the shoreline of a distant island by watching waves returning to the beach. IBEX detected energetic neutral atoms, particles created through interactions near the heliosphere's outer regions. By observing these particles, scientists were able to construct maps of areas that could not be photographed directly. The results revealed structures and patterns nobody had anticipated. One particularly surprising feature became known as the IBEX Ribbon, a mysterious band of enhanced particle emissions stretching across the sky. Its discovery provided important clues about the magnetic fields surrounding our solar system. Today, newer missions continue this work. Among them is the Interstellar Mapping and Acceleration Probe, known as IMAP. Building upon lessons learned from earlier missions, IMAP is designed to provide an even clearer picture of the heliosphere and the environment surrounding it. Together, these spacecraft are helping humanity answer a profound question. What does our neighborhood in the galaxy actually look like? The answer is becoming clearer with each passing year. The solar system is not isolated. It is embedded within a larger environment, a changing environment, an environment shaped by gas, magnetic fields, and ancient stellar history. And perhaps most fascinating of all, that environment behaves almost like a form of weather, not the weather of clouds and rain, but something larger, something that unfolds across light years, something that influences the very shape of the heliosphere itself. And it is this galactic weather that helps determine what kind of cosmic sea our solar system is sailing through today. When most people hear the word weather, they imagine clouds gathering above a city, rain tapping against a window, or wind moving through trees. Weather feels familiar because we live inside it. Every day, whether we notice it or not, the atmosphere around Earth is constantly changing. Air moves, temperatures rise and fall, storms form, clouds drift across the sky. The environment surrounding our planet is never completely still. As scientists began exploring the solar system, they discovered something surprising. Earth is not the only place with weather. The sun has weather too. Gigantic eruptions occasionally burst from its surface. Powerful streams of charged particles sweep outward through space. Invisible disturbances ripple through the solar system. This environment became known as space weather. And as our understanding expanded even further, another realization emerged. The galaxy itself has something that resembles weather. Not weather made of rain or snow, not weather that changes from one day to the next, but a much slower and grander form of environmental change. A kind of interstellar weather. Imagine once again that the solar system is a ship crossing a vast ocean. The ocean itself is never completely motionless. Currents shift beneath the surface. Winds change direction. Temperatures vary from one region to another. Some waters are calm, others are turbulent. A vessel crossing such an ocean experiences different conditions depending on where it travels. The same is true for the solar system. The local interstellar cloud is not a perfectly uniform region. Its density varies. Its magnetic fields vary. The flow of particles changes from place to place. Even the broader structures surrounding it influence local conditions. In other words, our cosmic environment has weather. The timescales are vastly longer than those of Earth, but the underlying idea remains surprisingly similar. Conditions change, and those changes matter. One of the most important ingredients in this galactic weather is magnetism. Magnetic fields exist throughout the Milky Way. Unlike clouds or stars, they cannot be seen directly. Yet they shape the movement of charged particles across enormous distances. You might imagine them as invisible currents flowing through an interstellar sea. Most of the time, we are unaware of these currents, yet they help organize the structure of the galaxy around us. The local interstellar cloud possesses magnetic fields of its own. As the solar system moves through the cloud, those fields interact with the heliosphere. This interaction influences the shape of the sun's protective bubble. In a sense, the heliosphere behaves like a sail responding to changing winds. When conditions in the surrounding environment change, the heliosphere changes, too. Another important component of galactic weather comes from cosmic rays. Earlier, we briefly met these energetic particles traveling across the Milky Way. They originate from some of the most powerful events in the universe: exploding stars, violent stellar remnants, extreme environments scattered throughout the galaxy. For countless ages, these particles have streamed through interstellar space. Some eventually encounter the heliosphere. Many are deflected. Some penetrate deeper into the solar system. The number that reach Earth depends partly on the strength and structure of the heliosphere itself. This means that conditions far beyond the planets can influence the amount of cosmic radiation entering our neighborhood. The relationship is subtle but important. Interstellar environment, heliosphere, cosmic rays, Earth. A chain connecting our planet to events occurring across vast regions of the galaxy. This connection reminds us that Earth does not exist in isolation. Our world is part of a much larger system, a nested series of environments stretching outward into space. Scientists have spent years studying how changes in interstellar conditions might affect the heliosphere. One factor receives particular attention: density. The local interstellar cloud is extremely diffuse, but not all interstellar clouds are alike. Some contain more material. Some are significantly denser. If the solar system were to move into a denser region in the future, the heliosphere could respond dramatically. Imagine a ship sailing from calm open water into a region of stronger currents. The shape of its wake changes. The pressure around its hull changes. The vessel adapts to its surroundings. Similarly, a denser interstellar environment could compress the heliosphere. Its outer boundaries might move inward. Its shape might become altered. The protective shielding it provides could change as well. Scientists continue to investigate exactly how such transitions would unfold. Fortunately, these changes would occur over immense spans of time. Nothing like a sudden storm striking a ship at sea. The galaxy operates on a slower schedule. Thousands of years, tens of thousands of years, sometimes millions of years. The pace is so gradual that entire civilizations may rise and fall while larger cosmic conditions remain almost unchanged. Yet from the perspective of astronomy, these transformations are real. The solar system's environment today is not necessarily the same as it was millions of years ago. Nor will it remain identical millions of years from now. The sun is traveling, the galaxy is evolving, and the conditions surrounding us continue to shift. This broader perspective changes the way we think about our place in the universe. Instead of imagining the solar system suspended in an unchanging void, we begin to see it as part of a living environment, a traveler moving through regions shaped by ancient stars, a traveler influenced by magnetic fields stretching across light years, a traveler passing through invisible clouds of gas and dust. And like any traveler, the solar system carries its own history. Its present location is only one chapter in a much longer journey. A journey that has already carried the sun around the Milky Way many times. A journey that continues even now. As you listen, as Earth turns quietly beneath the night sky, as our star follows its ancient path around the galaxy. The story becomes even more remarkable when we step back and view that journey from a wider perspective. because the sun is not merely drifting through nearby clouds. It is undertaking one of the longest voyages imaginable, circling the Milky Way itself. For much of this journey, we have been focusing on the solar system's immediate surroundings: the local interstellar cloud, the heliosphere, the invisible weather of interstellar space. But there is an even larger journey unfolding around us, a journey so vast that it is difficult to grasp with ordinary intuition. The sun is orbiting the center of the Milky Way, not standing still, not anchored in place, but traveling through the galaxy as part of a grand celestial cycle that began billions of years ago. From Earth, the stars often appear fixed. Night after night, familiar constellations seem to hold their positions. The sky feels stable, permanent, almost timeless. Yet this appearance can be misleading. Every star in the Milky Way is moving. Some drift slowly relative to one another. Others travel in very different directions. The galaxy is not a frozen picture. It is more like a living city whose inhabitants are constantly in motion. And among those countless moving stars is our sun. Imagine standing on a hillside overlooking a vast river. At first glance, the water may seem calm. But if you watch carefully, you notice that everything is flowing. Leaves drift past. Branches float downstream. Small ripples carry objects along invisible currents. The Milky Way behaves in a somewhat similar way. Stars orbit the galaxy's center like leaves carried by an immense cosmic river. The sun is one of those leaves, and it has been drifting along this galactic current for billions of years. The speed of this journey is remarkable. The solar system travels around the Milky Way at roughly 220 kilometers every second. While you listen to a single paragraph, our entire planetary system has already moved thousands of kilometers along its path. And yet, despite this extraordinary speed, the Milky Way is so enormous that completing a single orbit takes an astonishing amount of time. Astronomers sometimes call this journey a galactic year. One galactic year lasts approximately 225 to 250 million Earth years. To appreciate how long that is, imagine traveling back in time by one galactic year. The world would be almost unrecognizable. The continents would look different. The climate would be different. Many familiar species would not yet exist. Dinosaurs were still thriving during some of the sun's previous passages around the galaxy. A single orbit around the Milky Way spans periods of time that dwarf human history. Civilizations rise and fall in what amounts to a tiny moment along this cosmic path. In fact, since the sun formed roughly 4.5 billion years ago, it has completed only about 20 to 25 galactic orbits, only a few dozen. That number often surprises people. After all, 4.5 billion years sounds unimaginably ancient. Yet the Milky Way is so vast that even billions of years allow for only a limited number of circuits. The sun is still relatively early in its long journey, and every orbit has carried it through different regions of the galaxy. The Milky Way is not uniform. Just as Earth contains deserts, forests, mountains, and oceans, the galaxy contains different environments. Some regions are rich in gas and dust. Others are more sparse. Some contain active, star-forming regions where new suns are being born. Others are quieter and older. The solar system does not remain in a single galactic neighborhood forever. It travels, slowly crossing different regions over immense spans of time. One of the most beautiful structures within the Milky Way is its spiral pattern. From a great distance, our galaxy resembles a graceful whirlpool of stars. Curving spiral arms extend outward from the central regions, wrapping around the galaxy like luminous streams. These spiral arms are not rigid structures. They are dynamic regions where stars, gas, and dust gather in greater concentrations. As the Sun moves around the Milky Way, it may pass through or near different spiral regions. Such passages can subtly influence the environment surrounding the solar system. Nearby star formation may increase. Interstellar conditions may change. The kinds of clouds encountered along the way may differ. In this sense, the solar system experiences something like galactic seasons, not seasons measured in months, not even seasons measured in centuries, but changes unfolding across millions of years. The galaxy slowly changes around us, and we move through those changes. This perspective transforms the way we think about our cosmic home. The solar system is not merely a collection of planets orbiting a star. It is a traveler crossing an evolving galaxy. At times, the journey passes through quieter regions. At other times, through environments shaped by nearby stellar activity. Ancient stars have influenced our path. Future stars will influence it as well. Every cloud encountered along the way becomes part of the solar system's story. The local interstellar cloud is one chapter, but it is not the entire book. Long before the Sun entered this cloud, it traveled through different interstellar environments. And long after it leaves, new regions will await. This realization can be strangely comforting. The universe is often described in terms of permanence, but movement may be the deeper truth. Planets move, stars move, clouds move, galaxies move. Everything participates in a larger flow. Even our own lives, brief as they may seem compared with cosmic timescales, unfold within that continuous motion. As you rest tonight, Earth quietly circles the Sun quietly circles the Milky Way, and the galaxy itself continues its own journey through the wider universe. Yet another layer of this story remains hidden in the background. Because the region surrounding the solar system today may have been shaped by events that occurred millions of years before humans ever existed. Ancient stellar explosions, long-vanished stars, gigantic shockwaves expanding through space. The traces of those events still surround us, and they may help explain why our corner of the galaxy looks the way it does today. The deeper we explore our cosmic surroundings, the more we discover that every layer exists within a larger one. Earth exists within the solar system. The solar system exists within the heliosphere. The heliosphere moves through the local interstellar cloud, and the local interstellar cloud itself resides within something even larger, a structure known as the local bubble. The name sounds gentle, almost playful, yet its origin may lie in some of the most violent events the galaxy can produce. To understand the local bubble, imagine standing in a forest long after a thunderstorm has passed. The storm itself is gone. The lightning has vanished. The rain has stopped. Yet traces remain, broken branches, wet ground, subtle signs that something powerful once moved through the landscape. Astronomers believe our region of the Milky Way may contain similar evidence, not of storms, but of ancient stellar explosions. These explosions are called supernovae. They occur when certain stars reach the end of their lives and release enormous amounts of energy into space. For a brief period, a single exploding star can outshine entire galaxies. Shock waves race outward. Gas is heated and accelerated. Material is scattered across vast distances. Over millions of years, these explosions reshape their surroundings. Scientists now suspect that the local bubble was created by multiple supernovae occurring in our galactic neighborhood long ago. Not one explosion, but many. perhaps a series of stellar deaths unfolding over millions of years. Each explosion contributed energy to the surrounding region. Together, they appear to have carved out a vast cavity within the interstellar medium. Today, the local bubble stretches across hundreds of light years. It forms a gigantic region of relatively low-density gas surrounding our corner of the Milky Way. In a sense, we live inside an ancient fossil. Not a fossil made of bone or stone, but a fossil made of structure. A lingering imprint left behind by stars that disappeared millions of years before humans ever looked toward the night sky. This realization adds a remarkable layer to our understanding of the solar system's environment. The local interstellar cloud is not floating alone. It exists within a larger cavity shaped by long-forgotten cosmic events. Like a patch of morning mist drifting inside a vast valley, the cloud occupies only a small portion of a much larger structure. And the story becomes even more interesting when we remember that nothing in the galaxy remains fixed forever. The sun continues its journey. The local interstellar cloud continues its journey. The Milky Way continues its journey. Movement never truly stops. For many years, astronomers assumed the local interstellar cloud represented our permanent surroundings. Today, the picture appears more dynamic. Observations suggest that nearby interstellar space contains multiple clouds. Some are larger, some are smaller. Some may possess different temperatures, densities, and magnetic conditions. Together, these clouds form a complex environment through which stars slowly travel. You might imagine them as patches of fog drifting across a landscape. A traveler walking through the countryside may move from one bank of mist into another without noticing the exact moment of transition. The boundaries are often subtle, gradual, difficult to define precisely. The same may be true for the solar system. Research suggests that our stay within the local interstellar cloud is probably temporary. On cosmic timescales, we may eventually leave this cloud and enter another region of interstellar space. No dramatic crossing will occur. No visible border will suddenly appear in the sky. The transition would unfold gradually over thousands of years. Yet from an astronomical perspective, it would represent an important environmental change. Different clouds possess different properties. Some contain more material, some contain less. Some may exert greater pressure on the heliosphere. Others may influence cosmic ray shielding in different ways. The details remain an active area of scientific investigation. Astronomers continue gathering data, refining models, and searching for clues about the solar system's future path. What might happen if we entered a denser cloud? The question has fascinated researchers for decades. A denser environment could compress the heliosphere, reducing its overall size. The sun's protective bubble might become more compact. Cosmic rays could gain somewhat easier access to parts of the solar system. The exact consequences would depend on many factors, including magnetic fields and the cloud's overall structure. Fortunately, such changes unfold slowly. The galaxy does not rush. Its transformations are measured in epochs rather than days. For the people living on Earth today, these future encounters remain distant possibilities. Yet they remind us of something important. The solar system is not standing still. It is traveling through an evolving environment. The destination is not fixed. The surroundings are not permanent. Our current cosmic neighborhood is only one moment in a much larger voyage. There is something strangely beautiful about this realization. The stars above may appear eternal. The night sky may seem unchanged. But hidden beneath that appearance lies a story of motion and transformation. Ancient stars exploded and created the local bubble. The sun entered the local interstellar cloud. The heliosphere adapted to its surroundings. Future clouds await farther along the journey. The universe is not frozen. It is alive with slow change. And perhaps that is one of the most comforting perspectives astronomy can offer. Even on scales so large that human imagination struggles to follow them, the cosmos remains a place of movement, evolution, and renewal. The solar system is not merely located somewhere, it is going somewhere. And to fully appreciate where we are, it helps to gather all the layers of this story together and ask a simple question. If someone asked for our address in the universe, how would we answer? As our journey through the galaxy gradually draws toward a resting place, it can be helpful to return to a simple question. Where are we? At first, the answer seems obvious. You might say you are in a room, or a house, or an apartment. You might name a street, a city, or a country. These answers are all correct, yet each one represents only a single layer of a much larger address. Imagine writing your location on an envelope. You begin with a room, then a building, then a neighborhood, then a city, then a nation. Each layer contains the one before it. The farther outward you travel, the broader the perspective becomes. The universe works in much the same way. Earlier tonight, we began with a person resting quietly on Earth, a familiar place, a world of oceans, mountains, forests, deserts, and cities, the only home humanity has ever known. Yet Earth is not isolated. It belongs to a larger family. The solar system, a collection of planets, moons, asteroids, comets, and countless smaller objects orbiting the sun. For many centuries, this was the largest environment humans could imagine. The known universe ended not far beyond the outer planets. Today, our perspective is much wider. We now understand that the solar system itself exists inside another structure, the heliosphere. A vast protective bubble created by the solar wind, invisible, enormous, traveling with the sun through the galaxy. Every planet lives within this bubble. Every spacecraft launched from Earth begins its journey inside this protective cocoon. For most of history, nobody knew it existed, and yet it has always been there, quietly surrounding us, quietly shaping our cosmic environment. But even the heliosphere is not the final layer. Beyond it lies the local interstellar cloud, the faint galactic mist through which the solar system is currently traveling, a cloud composed primarily of hydrogen and helium, a cloud so thin that it would seem almost empty by earthly standards. And yet this cloud represents our immediate interstellar neighborhood. It is the environment through which the sun moves today, a temporary region along a much longer journey. Beyond the local interstellar cloud lies the local bubble, a vast cavity likely sculpted by ancient supernova explosions. Long ago, powerful stars ended their lives and reshaped this region of the Milky Way. The traces of those events remain around us even now. The local bubble serves as a reminder that our surroundings are connected to a deep and ancient history. Every layer contains stories that began long before humanity arrived, and beyond the local bubble stretches the Milky Way itself, a galaxy containing hundreds of billions of stars, a vast river of light extending across unimaginable distances. Within its spiral arms, stars are born. Stars age, stars die, clouds drift, planets form. Entire solar systems travel from one region to another. Our sun is only one traveler among countless others. One star following its own path through an ever-changing galaxy. For much of human history, people imagined themselves standing at the center of creation. Modern astronomy tells a different story. Not a story that diminishes us, a story that expands us. We are not the center of the universe. We are participants within it, connected to structures far larger than ourselves, connected to processes that span billions of years, connected to stars that lived and died before Earth existed. The atoms in your body were forged inside ancient stars. The oxygen you breathe was created long before humanity appeared. The calcium in your bones once traveled through interstellar space. In a very real sense, you are part of the galaxy's ongoing story, and the galaxy is part of yours. Perhaps one of the most beautiful discoveries in modern astronomy is that location is not merely about where something is, it is also about where it is going. When someone asks where Earth is, we often imagine a fixed point, a position, a coordinate. But Earth is moving. The solar system is moving. The heliosphere is moving. The local interstellar cloud is moving. The Milky Way is moving. Everything participates in a larger flow, a cosmic river whose currents extend far beyond anything our ancestors could have imagined. This means our cosmic address is not static. It is alive, dynamic, changing. The address we occupy today is slightly different from the address occupied by the dinosaurs, and slightly different from the address that future generations may inherit. The universe is constantly rewriting the details while preserving the larger journey. There is something deeply comforting about this perspective. The night sky can sometimes feel distant, cold, unreachable. Yet the more we learn about it, the more connected we become. We discover that Earth is not isolated in darkness. We travel inside a heliosphere shaped by the sun. We drift through an interstellar cloud. We reside within a bubble formed by ancient stellar explosions. We orbit inside a galaxy filled with countless suns. And all of these layers fit together like nested worlds, each one providing context for the next. So if someone were to ask where we are, perhaps the most honest answer would be this. We are on a small world orbiting an ordinary star, inside a protective bubble of solar wind, drifting through a thin cloud between the stars, traveling within an ancient cavity carved by long-dead suns, circling the Milky Way on a journey that began billions of years ago and continues tonight. A remarkably long address, and perhaps one of the most beautiful ever discovered.